Alright, in this video I'm going to go over all the kinematics graphing problems that are on the second half of your practice test that you were doing on Friday for the first 40 minutes of class. And so let's start with number 6 here. It says fill in the table below. Then we have to complete the 3 graphs and then answer the items A through D. So we're going to fill in this table first. We can see we have a position, time, velocity, and acceleration. And so what we want to do first is remember that velocity equals delta, whoops, excuse me, pen here, delta x divided by delta t. Acceleration equals delta v divided by delta t. Okay, these are all vectors here. So we have to look at position, x, and then time, t. And so to calculate velocity, first of all, we cannot, let's use a different color here, calculate a velocity without an interval. So if I don't have a delta x, I don't know what came before 30 for the position. And at time 0, there is nothing before that. Okay? And so all I can do is go 28 minus 30, which is a negative 2. And then this would be my delta x. And then 2 minus 0 would be my delta t, and this would equal 2. So then I go negative 2 divided by 2. This would give me a negative 1. All right, I hope you can see how we did that. Let's now do the next interval. I have to do 24 minus 28. Now my delta x is going to be negative 4 divided by 4 minus 2, which is 2. Divide those. Negative 4 divided by 2 is negative 2. As I continue to go here, you'll see how I fill this in. This will be a negative 6 divided by 2. Negative 3. Let's go red. This will be a negative 8 divided by 2 seconds. It's a negative 4. And then finally, we have a negative 10 divided by 2 seconds. And then this is a negative 5. So you see a negative 1, negative 2, negative 3, negative 4, negative 5. Your velocity is changing. It's increasing. It's getting faster over that 10-second period. So now let's do the acceleration. Again, we can't have an acceleration here. Actually, we can't even have an acceleration here because there's no intervals. Okay? So the first interval we could actually do is negative 2 minus minus 1. Negative 2 minus minus 1 is negative 1. I have to divide this number, though, by that time interval right there. It's, remember, delta v divided by delta t. So it'd be negative 1 divided by 2, which equals negative 0.5. And actually, if you do all of these, you see that they all have negative 1 intervals. These are all negative 0.5 in this beautiful poopy brown color. Okay? So that's what you have right there. So now we can just do our graphs. So the first thing we got to do is make a scale. Let's do the time scale first. I have 10 seconds. I've got 5 lines here. So let's go 0, 2, 4, 6, 8, 10. So this is all t times t. T here, 10 seconds, 8, 6, 4, 2, 0. And then I'll do the acceleration as well, even though you can't see it. 6, 8, 10, 2. I'll put it up when it's time. So now let's do the position versus time scale. I see I'm going all the way from 0 to 30. How many lines do I have? 1, 2, 3, 4, 5, 6, 7, 8. I got 12. Well, let's just go by 5s. 5, 10, 15, 20, 25, 30. Okay? All right, let's graph. Let's see. At time equals 0, I'm at 30, so I'm right there. At time equals 2, I'm at 28, so 25, right about there. Time equals 4, I'm at 24, which is right about here. Time equals 6, I'm at 18, in between 15 and 20 about. Time equals 8, I'm at 10, it's easy. Time equals 10, I'm at 0. Hey, look at that. So I have this graph that looks like it's going from shallow to steeper. Okay, makes sense. Notice I have a negative slope. I'm going shallow, which means slow, steep, which equals fast. All right? So I already know I can answer these questions now. And actually, I'll do it. I have negative direction. I am slow to fast, and I am changing velocity. Changing velocity. Okay? So just by looking at this, I know I'm going to be below the zero for my velocity versus time graph. Velocity versus time. I'm going to be in the negative region because I got negative velocity. All right, here's the positive region. So let's draw the velocity real quick. It's, let's see here. At time equals 0, I don't have one. At time equals 1, I'm at negative 1. At time equals, I'm sorry, at time equals 2, yikes, let me change that. Time equals 2, I'm at negative 1. At time equals 4, I'm at negative 2. Time equals 6, I'm at negative 3. Negative 4, negative 5. I didn't draw my scale in. Here you go. Negative 1, there's negative 5. 1, 2, 3, 4, 5. That's right. And so my line, let's go bright green, is going to be just like this. And notice, if you're close to the 0, you are slow. If you're farther away from the 0, you're faster. Makes sense. I'm in the negative region. Okay? Now I can look at this. The slope of this line is negative. So I've got negative acceleration. My acceleration is negative. And so if I were to draw this graph down here, this is the negative, that's the positive. I'm just going to be down there. Okay? I'm not going to worry too much with you about how far you are from the 0. Just make sure you're in the negative region. So those are your 3 graphs. Okay? So basic. Now that's qualitative and quantitative, actually. Here's this one where you actually have to do some calculations. Let's remember a couple things here. This is a position versus time graph. Okay, position versus time. So remember, our slope is going to be our velocity. So let's look at this first. So what is the position at 0 seconds? Let's do number 9. The position at 0 seconds is 20. 0 seconds, I'm at 20 meters. What is my position at 3 seconds? Well, my position at 3 seconds, 2, 3, I'm right here, it is 60 meters. We'll calculate the average velocity from 0 to 3 seconds. Well, we know average velocity, v, okay, will equal delta x all over delta t. Okay? Our delta t is already given to us. It's 3 seconds minus 0 seconds. Our delta x is going to be 60 meters minus 20 meters. So 60 meters minus 20 meters. All right? This will give us our answer. 60 minus 20 is 40 meters divided by 3 seconds. Oops. 3 seconds. So 40 divided by 3, 13.33 meters per second. 13.33. Repeating, meters per second. And that's your answer for number 11. Number 11. 13.3 meters per second. Okay, there's number 10. Number 12, calculate the average velocity from 4 to 6 seconds. All right, let's do this in green. From 4 to 6 seconds. So I already know that my delta t is going to be 6 seconds minus 4 seconds, which is going to equal 2 seconds. All right, 2 seconds. So I have to calculate. So 4, I'm right here. I'm at 60 meters. At 6, I'm at 90 meters. Okay, so I'm going to go 90 meters minus 60 meters divided by 6 seconds minus 4 seconds. This will equal my delta v. Okay, so that's my delta x, change in x, and that's my change in t. This will be 30 meters divided by 2 seconds. 30 divided by 2. I That's right there, guys. Sorry. Equals 15 meters per second. And this is your answer to number 12. All right, finally, let's do number 13. Calculate from 3 to 9 seconds. Well, 3, you're at 60 meters, and at 9, you're at 30 meters. Okay? If I were to make a line, by the way, it would look like this. If this is position versus time graph, that should be a negative answer. And it's kind of shallow, so it's not, it's steep. So I'm going to go for this is number 13. Let me do it right here. 13 is going to go 30 meters minus 60 meters, all divided by what, 9 seconds, right? Minus 3 seconds. So this is going to equal negative 30 meters divided by 6 seconds. And this is going to equal negative 5 meters per second. Negative 5 meters per second. And that's your answer to number 13. All right. Good. Moving on. Figure 2. Ooh, look, I like these. From figure 2, draw the velocity versus time graph. So again, this is position versus time. So this is what I like to do for these. This is a positive slope. So this is positive motion. This is shallow, so it's slow. This is steep, so it's fast. And obviously it's changing. Okay, changing velocity. Okay, so I'm going to be positive here. So I'm going to be up in this upper region, above the 0 for my velocity versus time graph. I'm going to start off slow, going to start close, fast, and far. Connect the dots. There's my velocity versus time graph. I'm looking at this. This is a positive slope. Okay. Actually, let me do it in a different color. So this is a positive slope. That's why I am in the positive region in my acceleration versus time graph. Oh, it should be flatlined. Flat line. There you go. Okay. So that's A. This is V. Okay. So that's how we do figure 2. Easy. Figure 3. Ooh, now we got velocity versus time graphs. So we're going to be calculating acceleration. Very similar to the previous problem, except that was position versus time. Now this is velocity versus time. So in figure 3, what is the velocity at 3 seconds? Okay, 16. At 3 seconds, the velocity is simply 50 kilometers per hour, right? 50 kilometers per hour. 17. In figure 3, what is the velocity at 5 seconds? 5 seconds, you are at negative 50 kilometers per hour. 18. Acceleration from 3 to 5 seconds. Okay, so what this is going to be is my delta t. 5 seconds is my final time. 3 seconds is my initial time. Okay, this is delta t. Okay, equals. And then I'm going to say A equals, do this purple, delta V. Okay, my velocity at 5 seconds, was 50 kilometers per hour. Okay, this is my V sub F. So my V sub F is negative 50 kilometers per hour. My velocity at 3 seconds, this is 3. This is my V initial, it's my starting time. This is positive 50 kilometers per hour. All right? And so now we just do the math, and let's do this in orange. Equals negative 50 minus 50 is negative 100 kilometers per hour divided by 5 seconds minus 3 seconds, 2 seconds. This is going to equal negative 50 kilometers per hour per second. And that's your answer for number 18. This is number 18. Okay, number 18 is negative 50. Let's do that in orange too. Negative 50 kilometers per hour per second. Okay. Number 19, acceleration from 2 to 3 seconds. Hey, this is an easy one. Look at this. 2 seconds to 3 seconds. What do I got here? Flat line, no slope, no acceleration. 0 kilometers per hour per second. Okay? Average acceleration from 2 to 10 seconds. All right, 2 to 10 seconds. Let's get a different color here. Number 20. 2 seconds to 10 seconds. So 10 minus 2, my delta t is going to equal 8 seconds. Okay? So the question is, at 2 seconds, I am at 50 kilometers per hour. At 10 seconds, I'm at 0 kilometers per hour. All right? Those are my velocities. So that means my delta v for this problem is going to equal 0 kilometers per hour minus 50 kilometers per hour. So delta v over delta t is going to equal negative 50 kilometers per hour divided by 8 seconds. And then our answer, 50 is negative divided by 8 seconds. Negative 6.25. Negative 6.25 kilometers per hour per second. Don't forget your units. And that's your answer, number 20. Okay? So those are those problems for figure 3. Almost done. Finally. Velocity versus time graph. Draw the position versus time. Okay, so again, interpret this graph first. First of all, I'm in the positive region, so I know I have positive motion. Also, I'm away from the 0, so I'm going fast to slow. Obviously, since I am changing, I'm going to have a curved line for my position versus time graph, so let's draw that here. So I'm going to have a positive slope. I don't care where you start. You could start down here, you could start anywhere, but since I know I'm going to be positive, I'm going to start down here. I got to go fast. I got to go steep to shallow, positive slope. Steep to shallow. Don't worry about this middle line. It's all relative when it comes to position. See, this is fast because it's steep, slow, shallow, and this is positive velocity, changing velocity. Okay? Now let's look at this. What do I have here? I've got a velocity versus time graph that has a negative slope. That means for acceleration, positive, negative, I got to be below, and I'm straight like that. Okay? So that's how we do 22. And that is it. Okay, I hope this was helpful. And I hope you have an excellent weekend. I'll see you on Monday. Study. Practice. Bye-bye.